Okay, welcome back to this class. I hope you all are doing good. So today we are going to discuss about Dalton's atomic theory, as you can see on your screens. Dalton gave a theory about the matter. This was the first theory that explained properties of matter or that explained something about matter. It was in 1808. So this is the year. Let's understand what were the basic or some important postulates or main points of Dalton's atomic theory. So the first point says that all matter, whether it is in the form of elements, compounds, or mixtures, are made up of very tiny particles. Those particles were called as atoms. So in short, atom are building blocks of matter. Atoms are building blocks of matter. Okay. So whether it is a living matter like human beings, plants, animals, microorganisms, or a non-living matter, stone, pen, pencil, paper, wall, brick, cement. So every sort of matter is made up of atoms only. Second, atoms are indivisible. So when Dalton gave the theory, there were no concept about subatomic particles like electron, proton, or neutron. So that's why he postulated atom as indivisible, indestructible, okay, particle. Atoms are indivisible particles and cannot be created or destroyed. So atom can neither be created nor destroyed in a chemical reaction. This postulate came from Dalton's atomic theory. But after the discovery of electron and proton and neutron, atom no longer is indivisible. Atom can be divided into subatomic particles like electrons, protons, and neutrons. Third point was atoms of a given element are identical in mass and chemical properties. We can say that atoms of a given element are identical in physical and chemical properties. What does that mean? That means, say for example, we have sodium. Symbol for sodium is Na. Okay, so all the atoms that are there in sodium metal or that constitute sodium metal, they will show same properties in terms of their mass. Their mass will be same. In terms of their chemical properties, whatever chemical reaction one atom shows of sodium, so all other atoms will definitely show the same chemical reactions. This is what this third postulate means. Coming to fourth one, say for example, atoms of different element are different in physical and chemical properties. So we will compare atoms of different elements. Say for example, atom of sodium and atom of potassium. Compare two atoms, two elements and their atoms. Say for example, sodium and potassium, different masses, different chemical reactions. Potassium being more reactive and sodium atoms being less reactive as compared to potassium. So here, when we compare atoms of two different elements, so definitely they differ in their physical and chemical properties. They differ in their mass, they differ in their number of protons and neutrons, they differ in their chemical properties or reactivity. So that is how the fourth point is, that different atoms, different elements have different atoms and they differ in their properties in terms of physical and chemical properties. Fifth point says, atoms chemically combine in the ratio of small whole numbers to form compounds. Okay, so it is about combination of atoms. It's about combination of atoms. So atoms do combine. Same atoms can combine. Different atoms can combine. So they form different products. But it's not that atoms combine in any proportion. No. They combine in a fixed proportion by their mass. So we will come to this when we discuss about chemical combination of atoms. Okay, so there are two laws that we will discuss. Sixth point is the relative number and kind of atoms are constant in a given compound. Say for example, we have a compound H2O. In this given compound, the kind of atoms, that is hydrogen and oxygen, it will always be same and their number is always same. Two atoms of hydrogen combines with one atom of oxygen forms one molecule of water. So whenever water is formed, irrespective of the method of preparation or method of formation of water, the number of atoms, that is two atoms of hydrogen and one atom of oxygen, this will be constant. Whenever a water molecule is formed, relative number and kind of atoms are always constant irrespective of the method of formation. Okay, this is what they mean. Whenever water molecule is formed, always it contains two atoms of hydrogen and one atom of oxygen. Okay, so mass ratio we can also calculate, that is 1:8, that is mass of hydrogen, that is 2 divided by mass of oxygen, that is 16, and the ratio will be 1/8. So we will also discuss that in coming up videos. This was about Dalton's atomic theory. If you have any confusion, okay, so if you have any question related to Dalton's atomic theory or related to any postulate or related to any point in the given in the Dalton's atomic theory, please put that in the chat box. I'll make sure to answer that as early as possible. Take care. Bye-bye.